Okay, so class, class A. Silencio. Silencio. Okay.
Wait, so where are the rest of the that one?
Hola.
Where
We started chapter 5.
What? Hold on, give me a second. Give me like 5
Spanish
seconds.
one taker.
Chapter 5, triangles. Did you see that?
Did you know that the world is so thick it has 7 seas?
Can we hold off?
The world is so thick it has 7 seas.
Stop it. That was the worst joke I've ever heard in my life.
I like that. The world is so thick it has 7.
Oh my.
Right? It's clever.
Wait, why does the sea the world is so just like we have 7 oceans?
I was Ben.
No, but I mean like what's it like thick? Oh.
You get it?
Is this recording right now?
Priceless.
Yeah. Sorry, Faith. Yes. Did you make that up?
Hey.
That explains a lot more.
Hey, so everybody listen up now. So in 5.1, we talked through a lot of this so far. We talked about perpendicular bisectors. We said it's a segment ray line or plane that bisects a segment into two, cuts the segment into two congruent parts and is perpendicular to that segment. So we had the example here. We had perpendicular bisector theorem saying if a point on the perpendicular bisector, like point C, W, onward, then it's equidistant from the two endpoints of the segment. Then we have the converse of that, saying if the point is equidistant from the 2 points of the segment, then it's on the perpendicular bisector. So we have the point X and the point maybe W down here that were equidistant from these 2 points from the angle, the 2 endpoints of the segment. So it has to be on the bisector. But like this point up here and this point up here are obviously not equidistant from point A and point B. So it's not on the perpendicular bisector. That was the converse. And then we're going to do these examples. Set them equal, solved. Went through here, set a couple equals, solved. We did this already. We said, hey, look, hey, guess what? What? No way. It doesn't have to be through the middle of the vertex. Okay. And then we practiced bisecting your segment. This is where we spent a lot of time on last time was the actual construction of that with the compass and the straight edge, in which case a lot of us use a ruler as our straight edge. So we went through that, and then we ended up having finding the point of concurrency, which we said was where three or more lines intersect at the same point is called the point of concurrency. And they're called concurrent lines. And so here, point C was our point of concurrency. Then we had the circumcenter theorem. And I believe we stopped right after this, right? Okay, so let's talk about this real quick again, the circumcenter theorem. So if we have a point of concurrency, which after we did this, we went through and we found our perpendicular bisectors for each of these. And, but we actually constructed them. And they said, hey, when they all go through the same point, which they will, they'll always all go to the same point when we make the 3 perpendicular bisectors of a triangle, 1 perpendicular bisector for each segment, side of the triangle. This point where they intersect, the point of concurrency for the perpendicular bisectors, has a special name, and that special name for it is our circumcenter. So the circumcenter is where the perpendicular bisectors of the sides of the triangle intersect at a point that is equidistant from the vertices of the triangle. So here, point P is where the 3 perpendicular bisectors meet of this triangle. We can see it by the drawing of these are in fact perpendicular bisectors, perpendicular and bisecting these sides. They meet at point P, so P is what we call the circumcenter. We'll talk about why it's called circumcenter, but it's called the circumcenter. And so the circumcenter, P, is equidistant from each vertex. So A, B, and C are the vertices, the plural vertex, in this triangle. So it's equidistant from the 3 of them. So P is equidistant from A, B, and C. That's our theorem for the circumcenter. When we have the circumcenter, which is where the 3 perpendicular bisectors are concurrent, then that'll be equidistant from the vertices. So this circumcenter on our triangle that we constructed, this would be equidistant from all 3 vertices. guaranteed as long as you did our construction correctly, even though it's outside the triangle right now. So, and this would be the only spot that happens. So we're gonna use this now. So if we're on the back here, we have, so we're gonna flip the page. So we have segment KZ, segment LZ, and segment ZM are the perpendicular bisectors of this triangle GHJ. So perpendicular bisectors, so KZ is perpendicular to the side, and that means it also bisects it, which is a perpendicular bisector. LZ, so this is bisected. MZ, so this is bisected as well down here. Does that make sense so far as we read through that? That was quick. Maybe QUICC quick. The idea of perpendicular bisector. So we're saying this first sentence says KZ, segment LZ, and segment MZ are these perpendicular bisectors of the triangle GHJ. So this triangle, KZ, LZ, MZ are the perpendicular bisectors. So that means KZ is perpendicular to the side and it bisects this side. LZ is perpendicular to the side and it bisects this side. MZ is perpendicular to the side, so it bisects this side. So that's what we've done so far. What does that make point Z? All the circumcenter. Very good. Using some vocab there. That's our circumcenter, the point of concurrency for the three perpendicular bisectors. Use the given information to find the length of each segment. Note that the figure is not necessarily drawn on a scale. So if we go through here, we're given that ZM, Z to M, is 7. So go ahead and mark that. We're also given that ZJ is 25. It is in fact funnier than 24. And we're told that HK is 20.
What can you do?
Nobody expects this vanishing position. So we're supposed to find ZH and HG. Does anybody have any ideas on how we might be able to find one or both of those? Ian, what's your thought?
Fine. Well, I was gonna say KJ would be 20 because of the bisector.
KG.
Yeah, KG.
KG has to be 20. Can you say that why?
Because K bisects it.
Okay, so KZ bisects this, so GK has to be the same. So does that help us find HG?
HG.
Yeah, does that help us find HG then if we know that?
Yes, it does.
Oh, 40. Yeah.
Yeah, because it's going to be 40. So we know that the measure of segment HG is going to be 40. We can add the 20 and 20 together because it's bisected, right?
Right.
So we can go out of order sometimes. Sometimes. Gotta be careful. You gotta know when to hold. So, how could we find ZH though? What do we know about the circumcenter? Did we just learn something from a theorem? Equidistant from what?
All
The vertices.
So it's 25. So it's 25.
So what's 25? ZH, because it's circumcenter to a vertex, and the circumcenter Z to vertex J is 25. So that means measure of ZH has to be 25. Was that your thought too, Jacob?
I'm sorry, I kind of got excited.
Ooh.
Ow!
I thought you were gonna keep your elbow where it was, but you didn't. Sorry. My condolences. Question on this. Dink and dope. Okay. So in this diagram, the perpendicular bisectors of triangle M and P meet at point O and are shown dashed. Hey, stop.
I'm discussing a math.
Yeah, you're not discussing a math problem. You're Aubrey. So, meet at point O. The perpendicular bisectors meet at point O, and they're dashed. So if we can find indicated measures here, actually we're gonna skip this part for now. Hey, so let's go right here to the circumcenter on the bottom. The circumcenter is inside the triangle. That's where the circumcenter is located right now. We have the three perpendicular bisectors. Oh, I should have used a different color. The circumcenter is inside the triangle if
Oh,
the
yeah.
triangle is acute.
Had to hit him with the Viking team colors.
Skull. So we have the three perpendicular bisectors here, and they meet at the circumcenter out of class. So go to Mrs. Caniglia. So this is the circumcenter. This is an acute triangle, correct?
I was really scared.
Correct.
Yeah.
So in any and every acute triangle, you'll have the circumcenter being in the inside of the triangle. Every time it's acute,
Correct.
it'll be somewhere in the center. Now, if the circumcenter will be outside the triangle, if the triangle is, well, what kind of triangle is this? Obtuse, very good.
Big boy.
It has that big boy angle, okay?
Also, how does everybody think of Big Boy performing at the Super Bowl halftime show? Big Boy. There's a guy named Big Boy who performed.
No, it's not. It's Maroon 5.
Yeah, Travis Scott and Big Boy are gonna be there too.
Big Boy's not. It's Travis Scott.
So we have our circumcenter being outside the triangle here. And if you recall on the one we constructed, what kind of triangle was it? Well, it's obtuse as well. And where was our circumcenter? It was outside the triangle, so it holds true.
It was the one. That's definitely not.
It definitely is.
This
The top
one?
angle is obtuse.
This one?
Yep, the top angle is obtuse.
Best.
Okay.
It is.
What do you want to bet?
What angle you betting?
A free day of me not complaining about your dad jokes.
Ooh. So what happens if you win? You won't. What happens if you win?
You
A
can't.
day without dad jokes.
Okay.
Oh.
I bet I lose. Watch this.
You will. You would not have made that bet otherwise.
I didn't even pay attention.
She was betting that this triangle that we constructed on earlier was is not obtuse.
So that means
Oh,
Aubrey.
Woo! I'm gonna cast it in a later day.
Which
Let
one?
me guys like it.
Nice to meet you.
have her do this day and
Wait, so I can still complain today?
Yeah, I haven't cast it
Okay,
in.
cool. I have
So
Hours. Alright.
let's go to the if we go on the back.
My nail this video.
What you're hoping to get out of it?
I wasn't gonna hope to get out of
Wait,
it,
wait,
but I was
I'm
gonna hope to
confused.
deny it for a while.
so if she doesn't like want to do it and she like complains during like
We have undisputable evidence.
Then we'll have to go to another day,
yeah
and
then
then she'll get a punishment. No, she doesn't. We did like double or something, you know, your attention.
Don't be
Um,
weird.
What angle has to be like acute or obtuse?
Okay, so for an acute triangle, all the angles are
Okay.
less than 90 degrees, right? All the angles are acute.
Oh, that's right.
For an obtuse triangle, only one angle is obtuse because that's all it could be mathematically. So if we have a right triangle here, a triangle that's right like me, the circumcenter is going to be on the triangle, okay? So it's going to be on the triangle. What?
Sometimes I worry about your health.
Sometimes I worry
So
about
I appreciate your concern. So the circumcenter is going to be on that triangle. And specifically, it'll be on the hypotenuse. One thing I want to do real quick is I actually want to grab this my compass up here, and I want to show you why we call it a circumcenter. So it's called a circumcenter, and we can do this with any of the triangles. I'm going to go back and do it with the previous one just cause. So let's do it with this one.
I'm really upset.
Okay. Hey, listen up real quick. If I need one that measures correctly here. Oh, so close. Oh, wait. Well, I need to be a little more precise in this. Wait, so hey, you see how this one is pretty close to that corner there, being on the point?
pretty
Okay, so it is. So we're gonna say the circumcenter. If we do this, what is that?
That is
Oh, so
not.
it's off. So I need one of these to work out better than this for this to work. So if I do this, and we were to have it actually to where I could change the length of this compass, and we went around and did this, we could actually do it to where we do what's called a circumscribed circle, a triangle circumscribed in a circle. So what this would be is this would be a circle using the circumcenter, and you could draw a circle even distance, and it would hit all of the points. All the points would be on the circle. So if I was able to go a little bit wider with this, which I just barely cannot, then it would work out just perfectly to where it'd be on the point of each of these if I had the exact circumcenter. And you can do it with any of them. So I can do it with this one as well, to where I would draw a circle if I was able to reach. Once again, as you can see, it's like just off there, so it's going to be just off the others as well. And it goes all the way around and gets just off on each of these. But if it's a little bit longer, it would get it to where it's on those points. And so the circle would be what we call circumscribed, or the triangle would be circumscribed in a circle. So the triangle is inside of the circle. Kind of neat.
Okay, why do they have it like, okay, you know where I'm going?
Yes.
Why would they name it that? Because like, now I want it like, not like, it's just gonna like, I'm gonna say like I'm gonna say that once in a while. Like,
I think it's funny like how awkward of a term that is for you that you're saying that. So Ian's referring to circumcision, which is a medical thing that they do for males, typically at a very young age. Well, there's stories of this being done at other ages.
Oh.
Thank you. But anyway, I'm not going into details just because I don't think I need to, nor do I want to. But it relates to the word circum, which just means around.
But like, why is size?
It has to do with the root of the word. I can look it up and actually answer it more if you want, but it has to do with the root. The prefix of the word, the first part of the word is circum. So, hey, the circumference of a circle is the distance around the circle. It's like the thank you, the perimeter of the circle. That was what I was blanking on. Thank you. It's like the perimeter of the circle. So these points would all be on the circumference of the circle. They'd be around the circumference, around the distance of the circle. So another way we can remember circumcenter is that it's circumscribed inside of it. Anyway, I digress. So
I kept getting the like questions like the imaginary numbers with like the eyes. I don't understand how to do that.
that's what we haven't done
You
that
do
yet.
not need to worry
Hey,
about that.
so let's do example 5. So if we're graphing this and we're doing this on a coordinate plane, finding a circumcenter on a coordinate plane. So what we're going to do is we're first going to graph these points and make the triangle. So we first are going to graph the point and make the triangle. So we have -1, 5. I'm going to go ahead and graph that here. We have 5, 5 right over here. We have 5, -1 over here. I'm going to go ahead and connect these points. Well, that was pretty good actually. I'm pretty happy with that. So I graphed and labeled my points. There you go. I was wondering if anyone was going to catch that. There you go. So graph the triangle, label the vertices. We did step 1, okay? So if we're finding the circumcenter on a coordinate plane. So if we're not doing the construction of it, we're going to do it on a coordinate plane. So go ahead and plot these points if you haven't already, please. I know I kind of speed plotted those.
Those are actually pretty good lines, Mr. Costello.
Right?
I'm proud.
Thank you, Proud. I appreciate it.
Wow.
Yeah.
I wish my dad
So I was saying, like, there's a lot of impression in me on that one. So
Aubrey's
the second one, finding the midpoints of the side. How can we find the midpoints of the sides? Count, and you go to the middle, right? You can also do x plus x divided by 2, y plus y divided by 2. But if we're finding the midpoint of AB, we can count. We can say, okay, the whole thing is 1, 2, 3, 4, 5, 6 long. So the midpoint's going to be how far from each point? 3, going to be half the distance. 1, 2, 3. Midpoint's going to be here. And then what you do is we need to make draw a perpendicular bisection through the midpoint. Why would we want it to be perpendicular to this? And why do we need the midpoint? Why is that special?
Because it just is.
Circumcenter is where the three what meet?
Vertices.
Perpendicular bisectors meet. So here, if it goes to the midpoint and it's perpendicular to this segment, is it going to be the perpendicular bisector? Yeah, we just found it without constructing. So we go down to see BC, and let's do this midpoint as well. So the whole thing is 1, 2, 3, 4, 5, 6 long. So we go 3 from either one, and we do the same thing. Now, is it easier to find the midpoint of BC and AB than it would be to AC? That's why I chose those two to start with, right? Hey, do we see where they're meeting?
Yep.
Yeah, it's right here at 2, 2. And where is that? Is
It's
that?
a right triangle.
It's a right triangle, so it's on the triangle. Because if we look right above this, the circumcenter is on the triangle, and it's a right triangle. This is a right triangle, and so it should be on the triangle. So where is the circumcenter? Well, let's write it as an ordered pair. 2, 2, 2, 2. I wore the 2, 2 before in my youth, but it was like for like a dress-up thing one time.
Well, I would hope so.
So maybe I was really good at ballet, you know?
Yeah, but I don't wear. Talking to the wrong person about that.
You know what Faith is? She's gonna die laughing.
I hope she doesn't die. So,
You gotta have fun on the crucible.
Oh my god!
is that questions on how this works, how this process works? I know we just went through that really quickly. Question on that process. Alright, here's what we're gonna do. We're gonna start with some work time on the homework, and then we're going to do some notes at the end again. Woo! Because Aubrey loves that pattern.
No, this is stupid. Why would
Stupid, it's math.
I hate everyone? Oh my god.
That's rude.
You can't hate me more than I hate
Oh,
myself.
stupid dad.
Dang. No, you need to look at memes.
What do you think I do for a living?
For a living, you make money off it.
I don't know if I'm laughing because I actually think it's funnier for everyone.
Why?
Yeah.
Like, it's just so random.
These are like $1. They're not that expensive.
Goodness gracious. It's just so random. Like, it's not like bad. It's not like super funny. It's not like super clever. It's just random. What is it?
Why am I laughing? You know, I used to laugh at like actual jokes, and now I laugh at stuff like that.
Hey, don't do.
Oh my gosh. Okay.
1, 3, 14 through 17, 20.
Oh, yes.
I hate when people ask what I'm going to be doing in a year. Come on out, 20. Hey, so we're going to work on this for about 20 minutes. We're going to work on this for about 20 minutes, and then we're going to go on to 5.2, okay? So we're going to work on this for...
We're not, because we're gonna get back on track of doing notes for the first part of class, and then homework for the second, like a normal class of work.
My
Yes,
plan was
drill
to-
sergeant.
So upset about that, your voice started
Aubrey,
cracking.
my plan was to get back on track on Friday during the short day and do what we just did on Friday. But obviously that wasn't even working.
I'm just so upset about it. It makes
I
me
just so
so
upset about it.
Mr. Carlson,
You ain't gonna get any
God,
happier about it.
Thank you. I'm so done.
I
so
Mr.
done.
Carlson,
You guys need to stop.
okay, let's use this work time wisely. Once again, we're going to go about 20 minutes.
Or your girl space friend.